first define some important terms that we will be using during this discussion. Let us start with the topic for today is about mid-segment of triangle. Okay, we will be discussing about the theorem that involves mid-segment of a triangle. But before that, let us first define some important terms that we will be using during the discussion. Let us have the first one, midpoint. Okay, when we say midpoint, what do we mean by midpoint? Midpoint is a point that divides a line segment into two equal parts. So it is a point that divides a line segment into two equal parts. So if you have a line segment, let's say you have a line segment here. So a line segment is part of the line having two endpoints. Okay, so let's say you have segment PQ. Okay, so that is a line segment. It has two endpoints. Now say this line PQ has a midpoint. So a point at the middle of this line segment. Okay, it should be at the middle. It should divide the line segment into two equal parts. Okay, so therefore, if let's say this point is point M. Okay, let's say point M is the midpoint of PQ. So point M is midpoint of segment PQ. So if it's a midpoint, it should be at the middle that divides the whole segment PQ into two equal measures. So therefore, PM should be equal to QM. Okay, so this should be equal to this. So if the whole PQ measures, let's say 12 units, what should be the measure of PM? So if you will divide 12 into 2, that will be 6, right? So this is 6 units. PM is 6 units and QM is also 6 units. So that's what we mean by midpoint. So midpoint always divides a segment into two equal parts. Now let's have mid-segment. What is a mid-segment? A mid-segment is a line segment connecting the midpoint of two sides of a triangle. Now it means that a mid-segment can be found in a triangle. So if you have a triangle, okay, if you have a triangle, a mid-segment is a segment joining the midpoint of the two sides of the two triangles. Let's say this is triangle X, Y, Z. Now we have three sides. We have side XY. So what are the sides? The sides are XY, YZ, and XZ. So we have three sides in a triangle. Now when you say mid-segment, that is when you have a midpoint in the sides, in each side of the triangle. Let's say for side XY, let's say for side XY, let's say this is point P. Let's say point P is the midpoint of XY. So that's when you say midpoint, as we have already discussed, it should be at the middle of point X of side XY. It should divide this into two equal measures. So this should be equal to this, right? And let's say you have point Q, which is the midpoint of side YZ. So if point Q is the midpoint of YZ, therefore YQ is equal to QZ, right? Now, if I will join these two midpoints, if I will join point P to point Q, this is what you call the mid-segment. Okay, midpoint, midpoint. If you connect that, you get a mid-segment. So this is a mid-segment. Segment. Okay. So again, a mid-segment is when you join the midpoints of the two sides of a triangle. Now, if I have here another midpoint, okay, let's say I have here another midpoint for line segment XY. Let's say this is R. Okay, let's say point R is a midpoint of XZ. If I will join, so therefore point R divides XZ into two equal measures. So therefore these are equal, right? So if I will join point P and point R, this is again another mid-segment. If I will connect point Q and point R, which are both midpoints of the sides, therefore QR are also mid-segments. So when you say mid-segment, when you are connecting two midpoints of the triangle, of the sides of the triangle. Okay, so if point P is a midpoint and PY measures 3, therefore PX is also 3. If this is 5, this is also 5. If this is 7, this is also 7. Now if this is 3, 3, what is the whole measure of XY? This is 6. This is 10. And this is 14. So when you say mid-segment again, that is when you connect two midpoints of the sides of the triangle. You form a mid-segment. Okay, so let us discuss now the triangle mid-segment theorem. The triangle mid-segment theorem states that in a triangle, the segment joining the midpoints of any two sides of a triangle, or every time you are forming a mid-segment in a triangle, the mid-segment is always parallel. It's always parallel to the third side, and it's also half the length of the third side. What does it mean? So let's have that one by one. So let's say I have here a triangle. Again, okay, let's say this is triangle A, B, C. Okay, so the mid-segment theorem tells us that if you connect two midpoints in a triangle, which is also known as the mid-segment, every time you have a mid-segment, the mid-segment is always parallel to the third side. Okay, so again, let's say in triangle AB, point X is the midpoint of segment AB, and point Y is the mid-segment, or is the midpoint of BC. Now if I connect these 2 points, we have a mid-segment. So this is what you call the mid-segment. Okay, based on the theorem, the mid-segment of the triangle is always parallel to the third side. So these are parallel to each other. It means that no matter how you extend these sides or segments in both directions, they will not intersect. Okay, so it is parallel. So I can say that point X and point P, point Y are midpoints. Therefore, XY is a mid-segment. Now, based on the theorem, the mid-segment is parallel to the third side. So I can say that XY is parallel to AC. Right? So, therefore, XY is parallel to AC. Now, aside from being parallel, it also states that the mid-segment is half the length of the third side. Okay, so it's half. So notice that XY is shorter than AC. So it's not hard to identify which one is half of the other side. Okay, so XY is half of AC. So I can say that XY is equal to 1/2 of AC. Okay, so I can say that if AC measures 10 units and XY is the mid-segment of this triangle, which is parallel to AC, therefore XY is half of 10. What is half of 10? That is 5 units. Okay, let's have another example. Let's say you have another triangle. Let's say let's have this triangle. Okay, let's say this is triangle PQR, and point T is a midpoint of PQ, and point S is a midpoint of PR. So since these are midpoint, if I will connect this, if I will connect this two segment, okay, therefore I'll be able to form a mid-segment. So this is a mid-segment. Okay, since point T and point S are midpoint, if I connect that, that will be a mid-segment. So this is parallel to this, right? So again, the mid-segment is always parallel to the third side of the triangle. Okay? Now, so we can say that TS is parallel to PR. Also, TS is half of PR, right? So this is half of this. So if the measure of PR is, let's say this is 14 units, what is the measure of TS? That is 7 units. Okay, because it's half. Okay, another one. Let's say I have another triangle. Let's say I have triangle. Let's say this is triangle TOY. Okay, say I have triangle TOY, and this is point R is a midpoint of OY, and point U is the midpoint of TY. Since these are midpoint, if I connect them, I will be able to form a mid-segment. Now, RU, based on the theorem, is parallel to TU, right? So RU is parallel to TO. RU is parallel to TO. Also, RU is half TO. So it's always half the measure of TO. Now if this is half of TO and T in RU measures, let's say this is 8 units, what will be the measure of TO? If this is half of this, what is the measure of TO? Therefore, TO is, this is 8, not 18, so 16 units. So how did I get 16? I'll get twice of 8 units, okay? So this is half, I will get double of this to get TO, because TO is longer than RU. Okay, let's have more example here. Suppose I have here, we are asked to find the value of x. Okay, so let's have number 1, find the value of x. So if these are equal, therefore this is a midpoint, right? If these are equal, therefore this is a midpoint. If these are midpoint, therefore this is a mid-segment. So if this is a mid-segment, therefore this is parallel to this, and x is half of 18. So I can say that x is half of 18. How do we get the half of 18? We will divide it by 2, right? To get half of 18, you divide it by 2. So what will be your x? 18 divided by 2 is 9. Right? Okay, let's have number 2. So if this is equal to this, and this one is equal to this one, therefore these are midpoints. If these 2 points are midpoints, if I connect that, that is a mid-segment. Therefore, this is parallel to this. So therefore, to find the value of x, let us make an equation. That will be 5x. The mid-segment is half of 70. How do you get the half of 70? You divide this by 2, right? Now, how do we solve for x here? To solve for x, that will be 5x is equal to 70 over 2. It's better if you are going to eliminate first the denominator. So how do we eliminate the denominator? How do we cancel this? So the best thing that you need to do is to multiply both sides by 2. So we can cancel this out, right? Because 2 divided by 2 is 1. Okay, so that will be 2 times 5. So multiply this. That will be 10x is equal to 70. Divide by 10. Your x is equal to 7. Right? So if your x is equal to 7, what is this? Plug in 5 times 7 is equal to 35. See, 35 is half of 70. Okay, let's have this one. So if this is equal to this, therefore this is a midpoint. This segment is equal to this segment, therefore this is a midpoint. And if I connect these 2 points, that is a mid-segment. So this is parallel to this. And also, 3x is half of 84. So 3x is half of 84. How do you get the half of 84? You divide it by 2. So I want to eliminate 2 here. I will simply multiply both sides by 2. So I can cancel 2. So that will be 2 times 3 is 6x is equal to 84. Right? Then you divide both sides by 6. Your x is equal to, what's that? 84 divided by 6 is 14. So if your x is 14, this is 3 times 14 is is 42. Okay, so that's correct. Next, let's say you have here this triangle. This is equal to this segment, therefore this is a midpoint. This is equal, therefore this is a midpoint, right? If these are midpoint, therefore this is a mid segment. This is parallel to this. So let us solve for x. So x minus 1, the shorter one, the mid segment, is equal to half of 45. How do we get half of 45? Divide by 2. Okay, to eliminate 2, you multiply both sides by 2. So that will be 2 times x is 2x. 2 times negative 1 is negative 2 is equal to 45. Then add both sides by 2. 2x is equal to 47. Divide by 2. X is equal to 23.5. Okay, let's have another one. Okay, this is equal to this. Therefore, this is a midpoint. This is also a midpoint because based on the markings, they are equal. So therefore, this is parallel to this side, these segments. Okay, so therefore, the mid segment, which is 5, is equal to half of x minus 1. Half of x minus 1, just divide it by 2. Then multiply both sides by 2. So I can cancel this. 2 times 5 is equal to 10 is equal to x minus 1. Then you add both sides by 1 because we want to isolate x. So 11 is equal to x. Right? Let's have the next one. So 5x minus 2, that is the third side, and the mid segment is 4. Right? So these are equal. So therefore this is a mid segment, midpoint. These are equal. Therefore this is a midpoint. Therefore this is the mid segment, which is parallel to the third side. Now, the mid segment, according to the theorem, the mid segment, which is 4, is equal to half of the third side. So the third side is 5x minus 2. You get half of that. That is equal. So multiply both sides by 2. So I can cancel this. 2 times 4 is 8, equals to 5x minus 2 plus 2. So this is 10 is equal to 5x. Divide by 5. X is equal to 2. Right? So always remember that based on the theorem, the mid segment of a triangle is always parallel to the third side and half the measure of the third side. Okay, so mid segment of the triangle is always parallel to the third side, and also it is the measure of the mid segments is half the measure of the third side also. Okay.